Yes.
Okay, great. Okay. So it says a satellite is to be constructed in the shape of a cylinder. Okay, satellite's got to be the shape of a cylinder with a hemisphere at each end. Okay, with a hemisphere at each end. The radius of the cylinder is r and the height is h. See the diagram. The outer surface area is to be coated with a heat resistant material, which is very expensive. The volume is that. Okay. So remember, guys, before I look at the question, what do I do? What do I always do with these types of questions?
Equation.
Say it again. Amara, what say it again? Is your mic working?
The equation of the
What about
series.
yeah? So use the information that they give me. So they telling me here that the volume is pi over 6. Do you guys see that? They're telling me that the volume is pi over 6. So I'm going to say, okay, well, if they're giving me the volume, then I must write an equation for the volume. Do you guys see that? So pi over 6. What is the volume of this? What do you guys think the volume of this is? What do you think the volume is? Does anybody have an idea of what the volume could be?
Like the final volume.
An expression for the volume. Can we break it up
Yes.
into this? Do you agree these are the same, right?
Yes.
So what's two hemispheres together?
Circle.
Sphere, right? It's a sphere. So you've already got the sphere. And what about this? What is the blue? What's the blue? What type of shape is the blue? Volume-wise. What type of shape, guys?
Rectangle? I'm not sure.
Oh, the rectangle. Volume-wise, what type of shape is it?
A cylinder. I don't know.
It's a cylinder. Naima said it's a cylinder. So what's the formula for a cylinder? Volume.
Pi r squared times h height.
Okay, so the volume is equal to pi r squared h, right? Which is the blue. Okay, let's just actually write it in blue so you guys can have an idea. Pi r squared h plus the sphere, right? What's the volume of a sphere?
4 with pi r cubed.
Great. Okay. And what did we say the volume is?
Pi over 6.
Great. So do you guys see, just from them telling us the volume is pi over 6, we already have an equation. Do you see that?
Yes.
And look at the first question. Show that h is that. How can we do that?
You make h the subject of the formula.
Yeah. So you could maybe what can we do? Maybe what can we do to make h the subject?
You take the volume of the sphere over to the other side. We divide by pi first. With no?
Yeah, you can. Sure.
You divide.
You can divide by pi, so you get 1 over 6. Sure.
Then
What next? Do you want to take out r squared maybe?
And
So it becomes r squared h plus
Oh, I see.
4 over 3 r. And then you can divide out by the r squared. So it becomes h plus 4 over 3 equals 1 over 6 r squared,
And then you take over the 4 over 3.
which gives
R.
you this.
Yes.
Okay, you guys will see that.
Yeah.
Amaro, Nabila. Was that Nabila? Was that repeated?
Yes. Yes,
Okay.
please.
Do you agree with this part here? 1 over 6. Sorry, not 1 over 6, pi over 6 equals the volume, right? This is the volume. Do you agree with the volume?
Yes.
Okay. Now, they want us to make h the subject of the formula. So Rivka said, let's first divide out by pi, which gave us 1 over 6 equals r squared h plus 4 over 3. We just divided out by pi, okay? Okay. And then we factorized r squared. Do you see that? They've got a common factor of r squared, Nabila? And then it became h plus 4 over 3r.
Oh, okay. I see what you did.
And then you divide by the r squared, and then you get h plus 4 over 3r equals 1 over r, 1 over 6 r squared. And then you solve for h. Oh, okay.
Oh, okay. Okay.
So that's h. Okay. So do you guys have an idea as to why they asked you to do that? Does anybody remember? Naima, do you know why they would have asked you to find r h first? Does anybody remember why we said we must find h first?
Because then you can substitute it into the other formula for the surface area. And then it
Yes,
will,
but
then it
and then why?
won't be,
Yeah, Rico?
then it will, like it will only be, there won't be a H because you won't have any other thing else. I don't know how to say it. Okay, but
Yeah.
yeah,
It's only one variable.
there we go.
It's only one variable. And you guys, in your syllabus, you only taught how to differentiate with one variable, so that you have to try and create only one variable. Okay. And that's why you find h, so that you can sub in. So now it says hence. You see how clever they are. They say hence show that the surface area, the outer surface area, can be given as that. Now, I don't worry about this. Don't worry about this. Don't look at this stuff here. Don't look at that stuff yet. Work with what you know. What is the surface area of the cylinder? Okay. What do you guys know? Do you guys know anything about the surface area of a sphere? It's here.
4 pi r squared.
Pi r squared, right?
Yeah.
And what about the curved surface area of the cylinder?
2
2
pi
pi
r
r
h.
h.
Plus two. They're very kind to you in this question, right? Because in other questions, remember, they didn't give you the formula. Guys, they didn't give you the formula.
Yes.
So that's why I would memorize the formulas in any case, just in case they don't give it to you. Or you can work it out.
Are these formulas not on the formula sheet?
I don't think so. I don't think they're all there. The thing is, I feel like they will be kind to you and give it to you, but we've also made concept videos on how to understand the formulas. So then you don't actually have to look at the back of the formula sheet to save you time. But anyway, that's the surface area. So what can we do here?
You substitute the thing that we found for h in 10.1, you substitute it into h.
Right.
There we go.
So so it becomes 4 pi r squared
Plus 2 pi r, open brackets, 1 over 6 r squared minus 4 r. over 3.
And how do we expand that? So it becomes 2 pi r, okay, a third pi r cubed, right? It's going to be a third pi r cubed. Because it's 2 over 6 minus 4
8
pi
over
r
3.
squared.
Oh, yeah. Mm-hmm.
6 pi, sorry, 6 pi r squared. Or minus, yeah, minus 8 over 3. Right? 8 over 3?
Yes.
Pi r squared.
And what is 4 pi r squared minus 8 over 3 pi r squared? How, you know, yeah.
It will be 4 over 3 pi r squared.
Because isn't 4 just 12 over 3? Then you can okay, so then you get that. Do you guys all see that?
Yes.
So you see, I don't bother with this whole stuff here, because this will make, I mean, it makes me look very like don't look at this stuff, because it makes you very overwhelmed when you see all this stuff. Rather just say, okay, they want the surface area, let me write down the formula for the surface area, and then if you just follow the maths, it will take you to this point. But don't start off by looking at this, because it will make you overwhelmed. At least it makes me overwhelmed when I used to look at that stuff. Okay. Okay, so is everybody happy with the first 2 questions? Nafisa asked the question. Are you happy, Nafisa? Nafisa, oh, she's not here.
I'm
Oh,
here.
yes.
I'm here. I didn't ask the question, but I get it.
Oh, was it Amaro who asked
Yeah,
it? Okay, Amaro, does
I
it make
think
sense?
so.
Yes. Yes.
Okay. The minimum. Calculate the minimum. Okay, so we've done questions like this before. Who wants to explain what we do here? Naima, do you want to give it a go?
Find the derivative and make it equal to 0. I think.
Great. So great. So you guys all get that?
Yes.
If this is surface area, okay, find the derivative. So who wants to do the derivative of this one? Rivka, you want to try? So it's going to be ds by d.
D. What are we?
Not x.
No,
There's no x
dr.
here. Dr. Okay. Remember, this is always going to be what's there, and then this is just going to be what's the other variable. Okay. So what you're going to do, Rivka?
It will be 4 over 3 times by 2, which will be 8 over something.
8 over 3.
Yeah, 8
Oh, okay.
over 3 pi r, and then
Yeah.
we'll bring the 3r. Want to be
Yeah.
3 3r to the power negative 1.
No, so you don't bring the 3.
Oh wait, no. You bring then it will be negative 1 over 3.
Do you guys all
Or
see that? Do you guys see that you're not going to bring the 3 over?
because it is 1 over 3.
Bring the r over. So it's pi over 3, which is a constant, times r to the negative 1. Okay.
So it'll be negative pi over 3 or
Yeah.
to the power negative 2.
Great. Okay. Which you can then bring the r squared down again into the denominator.
It'll be r squared.
Right. And what about this equation? That's
It
the
will be
derivative.
equal to 0.
Equal to 0. Okay. We can divide out by the pi, right?
Yes.
Take the pi away. Pi away. And then what can we do? We can take the thing over, so it becomes 8/3 equals 1/3 1/3 r squared. So we can, what can we do? We can take the 3 away, because we can multiply by 3. So what can we do now?
Can't you? I'm not sure.
Naima, do you have any idea?
I don't know. I was thinking, okay, no, I don't know.
Sydney, any ideas?
No, I'm also not.
Anybody have an idea?
Do we make r to the power, a negative exponent again?
Can't you
Yeah, cross. No,
Yeah.
cross multiply, and then you take the 8 over and you cube it.
Yeah, so it's r cubed equals 1/8. You multiply, and then you divide the 8.
Yes.
So therefore r equals
R equals. I'm not sure. 1 second.
Half.
Half.
because the 8 is just a half cubed, right? So then
Yes.
r cubed is going to be, r is going to be half. But is this the answer to the question? Is the answer r equals half?
No.
No. Why not? What is this? What does this mean?
What is what? Oh. It's at that point where the derivative equals 0, you can find the maximum and minimum.
So what must you do to find the minimum?
You sub it into, you sub r into the original.
Correct. Because isn't the original equation the surface area equation?
Yes.
So you want the surface area, so you will sub it into the surface area equation. If you subbed r into the derivative equation, what would it give you?
0.
Yeah, because it's a derivative. Or this is the derivative equation. So if you sub in half into the derivative equation, it's going to tell you the derivative at that point. But you just solved for it to be 0. So remember, you must always understand the equation. The equation is, if it's the derivative, it's going to tell you the gradient if you sub it in. But the original equation is going to tell you the y value, and the y value is the surface area. Okay. Everybody happy?
Yes.
Okay. Sydney, that question you sent, we've answered before in a previous video. I think, did you see the video I sent?
Which
Sydney?
the one of function?
Yeah, I sent a video we answered in the previous live session.
Which
Okay.
one? Because I sent one question.
I sent you the link. I sent the link in the group. Do you see in the group? I replied to your picture with a YouTube video. I gave you the timestamp also. So if you just click on the link, it takes you to the time in that video where we did that question. Okay.
Wait, which one? Because there's question 6, the one that has a function, or the one, which one?
No, I mean the question 6. Question 6.
Question 6. Oh, you've already done it. Okay, I'll check.
Yeah.
Right.
Okay. Let's do the next one. Afisa's question. Okay. Okay. Calculate the value of cos 2, sure, okay, the root 3 sine minus 2 over 4 sine 346 times cos, sure, okay. This is an interesting one. So they say without a calculator, so you have to try and manipulate it. So if I look at 346 is 14 away from 360, and 194 is 14. There we go. There we go. Okay. And okay. Okay, do you guys see the link here? 346 is 360 minus 14. And 194 is 180 plus 14. Do you guys see that?
Yes.
You see, you have to try and connect it to a common value. I have a feeling that these will cancel soon. But anyway, let's just see. What's sine of negative x? How do we change that?
Negative sign, yeah.
And how did you do that? Do you guys remember the 3 steps I told you? Which quadrant is it in? Which quadrant is sine negative x in?
In the 3rd and 4th.
No, well, this one, no. This particular angle, remember, negative x is in the 4th quadrant. So if I draw the cos diagram, remember, if you go from negative, you're going this direction. So it's the 4th quadrant. Do you see that?
Yeah.
360 minus x and negative x is the same. Okay. So it's the 4th quadrant, and sine is negative in the 4th quadrant. And because it's the 4th quadrant, it's 360, it stays the same. So it's negative sine x. So immediately I can change that to be cos 2 plus or minus root 3 sine 2. Do you guys agree?
Yes.
So now the angles are the same. Okay. Sure. Okay, so let's try and work with the bottom one first, because I'm not sure what's happening at the top. Let's look at the bottom. So 4 times sine of 360 minus 14 times cos of 180 plus 14. Do you guys see that?
Yeah.
Okay. So what's sine of 360 minus 14? If you apply the reduction rule. So there's a concept video on reduction, eh? If you guys want to revise reduction, okay? It's going to be negative sine 14.
Yeah.
And what about cos 180 plus 14? Which quadrant is that in?
Negative. It's going to be in the 3rd quadrant.
Yeah.
Oh, okay, I see it now. Okay. Okay, so say it again. Sorry, say it again. What did you say? Cos 180 plus 14?
Is in the
Negative
3rd quadrant. So it's going to be negative cos 14.
Yeah. So it's, and then so therefore this is going to be plus 4 sine 14 cos 14. Right? Do you guys agree? Because negative.
Yeah.
Any idea about what we could do for this?
Take out the 2 and put okay, take out 2 times 2 sine 14 cos 14 because then there'll be an identity.
Yes.
Sine 2. Yeah.
Yes. Okay, so it's going to be 2 times 2 sine 14 cos 14, right?
Yeah.
So what does that become?
That becomes 2 sine 2 14.
No. Yeah. So what is 2 times 14?
Oh, 28.
Okay. Now, I think we've got it, but let's just wait. Let's just wait a bit. Let's just wait a bit. Okay. Let's not get too excited. So let's just put that there. Okay. So now this whole thing, 4 sine 346 plus times cos 194 is just 2 sine 28. How cool is that, right? How cool is that, right? So, okay. Let's just ungroup that and bring that there. That's that. Okay. Now, my question to you is, how can we connect 2 to 28 using a special angle?
It will be 30 minus. No. I don't
Yes.
know.
Yes. 30 minus
30
2 is
minus
equal to
2 equals to be 28.
30 minus 28, right? Do you see that? Why am I bringing 28 in? Because I've got 28 here. So I'm probably gonna want to have 28 in my expression. So let's rewrite that. Cos of 30 minus 28, which is what? Isn't it a compound angle? Minus root 3 times sine of 30 minus 28. Isn't that also a compound angle? Do you guys agree?
Yes.
Okay, so what's cos of 30 minus 28? Remember, this is without a calculator. So I'm using 30 because I want to use special angles, right? And I'm thinking the 28 will cancel with this 28. That's why I'm using 28. You guys will see that.
Yeah.
Okay, so
cos 30
yeah, cos 28.
20 plus sine 30 sine 28
Right.
minus root 3
Minus root 3, yeah. Open brackets.
and then I think it's sine 30 cos 28 minus
Right.
cos 30 cos 28.
100%. 100%. Great. So sine 30 cos 28 minus, right? Why is it minus? Because it's sine. Because it's sine compound angle. Cos 30 sine 28. Now I'm just working with the numerator for now, but we're going to bring in the denominator later on. Okay. So, okay, let's see what we've got here. We've got let's just multiply out by the minus root 3. So it's minus root 3 sine 30 cos 28 plus root 3 cos 30 sine 28, right? You guys all agree?
Mm-hmm.
Yes.
Okay. Do we have like terms? No. It's okay. What's cos of 30 equal to? Here's the special triangle.
Root 3 over 2.
Right. So just the nice way I remember it is that sine of 30 is a half. So if I put 30 here, no, sorry. 1 is here. Okay. So cos 30 is therefore root 3 over 2, right? Cos 28. Plus a half. Sine 30 is a half,
A
right?
half.
Okay, and then what's minus root 3 sine 30 is minus?
Minus root 3 a half over 28.
Yeah, so this must be root cos 28, eh?
Yeah.
Cos. You write too fast. Okay. And then wait. So it's minus root 3 over 2, right? This red, it's minus root 3 over 2. Because sine 30
Yeah.
is off. Oh goodness, what happens? Okay. And plus root 3, what is cos 30? Root 3 over
Root
2.
3.
So it's going to be plus 3 over 2, because it's root 3 times root 3, sine 28. Oh my goodness. What happens here?
They
Oh,
cancel.
yes, and what is sine 28 over 2 plus 3 over 2 sine 28?
It will be
Isn't this off? Somebody's mic.
It will be 2 sine 28. Oh, and then it will cancel. So it
Oh,
will be
yes.
1, the final answer.
At the numerator, the denominator is 2 sine 28. Sure. And then the final answer is 1. Okay, Nafisa, did you see that? I know you asked the
Yes,
question.
such a long process just to get one.
But do you see how, like, I didn't, like, do you see how we try and bring in angles that are similar? So I started with the denominator. So actually the trick was to start with the denominator on this question, actually. Because from the denominator, like, always related to the special angles. So 346 is 14 minus, and this is 14 plus. So I knew there was something going on there. I didn't know what was going on there, but I knew there was something going on there. And then from this, we got 28. And then I thought, okay, 28, listen here, that's actually 28 plus 2 is 30. So that's another special angle. So yeah, that's how we got to this one. Does everybody understand?
Yeah.
It's all very logical process. But this just comes with practice. Okay, so let's look at the next question. Okay, so Hamza's question, that's a concept video. I don't know if Hamza's here. Hamza, your question on the cos A plus B, I sent you a concept video on that question. Okay. So Sydney, let's do your one. Sydney, did you manage to watch the concept video on functions? Sydney?
Yes, I did. There was there was this other video I used to watch which used to remind me. So since we back on functions, I kind of forgot everything. So when I watched the concept videos, I understood and did some of the questions because this previous questions. So I did one of them, and when I checked, some I did not get correct, which are the ones I highlighted. So
Okay, which ones did you highlight?
I highlighted it was B and
Okay.
C.
B, C. Okay. And then in the other one, there were 2 pictures.
The other one it was only E and H, but surprisingly I was able to to determine the equations of others, but when it came to other, since the functions are different, I was able to do some, but some I did not.
No, it's okay. Okay, so is it B, C, E, and H?
Yes.
Okay, great. Okay, sure. Okay, so what type of graph is B?
It's a hyperbola.
It's a hyperbola.
It's a hyperbola, right? So, so when drawing hyperbola, the first question I ask myself is, where are the asymptotes? So where are the asymptotes for this hyperbola over here? So we're doing B now. Sorry, we're doing B. Where are the asymptotes for B?
-1. Oh,
Yeah. Okay, yes, that's fine. The x asymptote
and
is 1
0.
here. And where's the horizontal asymptote?
It's 0, I think.
Y equals 0,
Yeah.
right? Well, y equals 0. Sydney, do you see that?
Yes, I do.
Okay. So what does that mean? Is the graph shifted up or down? If the y asymptote, the x asymptote is at 0? It's not shifted up, right?
Yeah.
It's just staying where it is. It's shifted to the left by 1. Do you agree?
Yes.
So therefore, we can conclude so far that y equals, we don't know a yet. It's going to be x plus 1, and then q is 0. There's no q value because it's not shifted up or down. Sydney, do you see that?
Yes.
So how can we work out a? Do you have any idea?
We sub in the points as a coordinate.
You can do you see they gave you a point here, Sydney?
Yes, I do.
So that you can sub in -1 equals a over 1 plus 1, which is 2. Therefore, a equals -2. Okay. Do you see that, Sydney?
Yes, I do.
Okay. But do you guys understand why it's negative? A is negative. Could you have predicted that a would be negative?
Yes.
Yes,
How would you know that a is negative?
because
Because it's in the second
the-
and fourth.
and yeah,
Yeah, that's
quadrant.
another trick. If it was in the first and the third, then you
It
could
is
say a is
positive.
positive. Okay. So let's do C. This is a exponential function. How many asymptotes does an exponential function have?
1.
1. And where is the natural asymptote? So for a normal exponential function, where's the natural asymptote?
It's 0.
Oh,
Don't say 0. Tell me equation. Because if you say 0, it could be x equals 0 or y equals 0.
y equals
Y
Yeah,
equals
y.
0. Because remember, what is the line of x equals 0? What's the line of x equals 0?
A vertical line.
vertical line.
Right, okay, because along this entire line, y is equal to 0. That's why the equation is y equals 0. But along the vertical line, x is always 0. That's why they say x equals 0. So now, what is q? If this graph is normally at the y-axis, the asymptote, now the asymptote is where?
At 1.
At 1. So what's q?
1.
Q is going to be 1. Sydney, do you see that?
Yes.
Okay. Right. Okay, so now we've got y equals a times b to the power of x plus 1. So now we need a and b. So what else can we do?
We can sub in coordinate
Yeah.
1 and 7.
1 and 7. So we can sub in 7 equals can you guys see the red? Must I change the color?
It's fine.
Okay, 7 equals, okay, it's fine. Yeah, 7 equals A times B to the power of,
7. 1. Sorry, 1.
okay, plus 1. And in the next equation, we can sub in 0.3. So that's the y-intercept, right? So 3 equals A times B to the power of 0, which is?
1.
So what's
1.
A?
Oh, A is 2.
No, 2.
2. I just skipped a step there. It's B to the power of 0. Sydney, do you see we're subbing in the different points?
Yes, I do.
So the nice thing is when you want to work out equations, just sub in points, sub in information, and that's the nice work. Okay, so A is 2. So if A is 2, and we said that 7 equals 2 times B plus 1 from this equation, 2B equals 6.
So B will equal 3.
All right. So the final equation, y equals 2 times 3 to the power of x plus 1.
Plus 1.
Great. Okay. Percy, I mean, Sydney, sorry, I have a friend called Percy. Sydney, does it make sense?
Yes, it does. Thank you.
Okay. Great. And let's do the next one. Okay. E. Okay, this is a parabola. Okay, so the nice thing is that P and Q. Sorry, yes, sorry. P and Q is hyperbola. So P and Q is just the horizontal and vertical shift. So for this, I just use the asymptote. So how is this graph shifted?
It shifted down
Down?
And 2
and
to
to
the
the left.
By 1 unit, and to the left by
By
2 units.
Yeah, so -2. Okay. So, and you can use this point here to help you. Because this point is actually tracing you. The intersection between the asymptotes actually tells you the journey. So it goes down by 1 and then to the left by 2. That's how I do it. So if I ever see the intersection, I just ask myself, you were over here one day. Once upon a time you were here. And now you're here. So you have to go down and then to the left. So that tells you how the graph is shifted. So that means that y equals A. We don't know A yet, but which quadrant what is the sign of A?
negative.
It's
Negative,
negative.
because in the second and fourth quadrant, it's going to be +2. Do you guys understand why it's +2? Because it's shifting to the
Yes.
left. And then we can sub in -4, 1 to give us A. So it becomes 1 equals A over -4 plus 2, which is -2 minus 1. A equals minus
A equals to negative 4.
4.
Yeah.
Which makes sense, right? Because it's in the second and the fourth. So if you got a positive answer for A, you know you're wrong. Do you guys see that?
Yes.
Yes.
You get a positive answer, but you know the graph is in the second, you know it's not right. Okay. And then the last one is H, exponential. Okay. There's no vertical shift, and they tell us that because they don't even have a Q there. So we just have to work out B and P. And we've got 2 points. Do you see that?
Mm-hmm.
Yeah.
We've got 0.3 and 1,1. So if we sub in 0.3, because I think 0.3, yeah. If we sub in, no, actually no. So we can just sub in 1, it just doesn't actually matter. We sub in 1,1, so it's 1 equals b to the power of 1 plus p, which is, if we use our exponent laws, b times b to the p. I'm not sure if that's going to help us, but anyway. And then we sub in this point here, which is 0.3, so it becomes 3 equals b to the power of 0 plus p.
So
So it's just b to the power of p.
so then it will be b will equal to 1/3 because b to the
Yes,
power of p, you
yes,
can sub it into that other equation.
yes. Do you guys see that? The only difference, if you you could actually divide out by b to the power of p. Was it the same?
Yeah.
And then you're left with b equals 1/3.
Yes.
And if you, in the concept videos, we explain that if b is a fraction, that means that it must be it means that if b is a fraction, means the function is going closer to 0 as we go closer to the right. Why? Because what happens to a fraction when you multiply it by a larger number? It gets smaller and smaller and smaller, right?
Yes.
So that's why as you go from left to right, what happens to the function? It goes closer and closer to 0. So, and then we can work out p because we've got b to be 1/3. So it's 1 equals 1/3 to the power of 1 plus p. We could say that 1 is just 1/3 to the power of 0.
So then p will equal to -1.
Right. P equals -1. If we sub in 1, what happens?
It will equal to y equals to 1.
So that's why you see it makes sense there. And if we sub in 0, it's 1/3 to the -1, which is just 3.
Yeah.
Okay. Sydney, does it make sense?
Yes.
So you see, it's a very similar pattern for all these questions. You
Yeah.
have to know that's why I say you must know. You see, every equation in maths has a meaning, right? So like, it has its own meaning. So P is just the horizontal shift. Q is the vertical shift. So if you know what the letters mean, then it becomes a lot easier to understand what's happening to this graph. And that's why sometimes I tell students that if I gave you a function, before drawing it, you should be able to know how it looks. If you know the properties, so like if I gave you an equation like y equals -3x squared plus 4, without even drawing this, I want you to actually be able to picture the graph. So if you asked me, Elias, what is y equals -3x plus 4? Well, I would tell you that it's a frowning parabola that is shifted up by 4 units. And it's centered it's not shifted to the right or to the left. It's only shifted up by 4. Do you guys see that?
Yes.
Or if I gave you a hyperbola, which I said is -1 over x plus 1 minus 3, just from you telling me this equation, I will know that this graph is shifted to the left by 1, and it's down 3, and it's in the second and the fourth quadrant. Do you guys see that?
Yes.
Yes.
So just before you see why am I saying this? Because your equation tells you things. The equation gives you information. And that's why you have to, so this is maths, you have to translate this to English. So in English, that means I'm shifting the graph to the left and down by 3, and I'm going to be in the second and the fourth quadrant. all of that is told to you by this equation. All of that is told to you. So that's why you have to study, the mechanics of the equation. Like, what does it mean when I say, what does it mean when I say y equals a times x minus p squared plus q? What does that mean? It means p is the horizontal shift, q is the vertical shift, and a tells me if it's a frowning or a smiling parabola. You just get the idea behind it.
Yes.
Okay. So let's go on to the next question. It's another trig one. Okay. Mhm. Simplify. Okay. So this is reduction. So you guys, let me just revise. Is everybody comfortable with reduction, or must I go through the steps again?
Can you go through the steps again, please?
Okay. So just a reminder about the course diagram. What did we say? What acronym do you guys use for the course diagram?
All stations to Claremont.
Yeah, but there's no Claremont in Joburg now. What do you what do you use for? What do you use to tell you about what's your acronym for the course diagram?
Take cocaine.
What? Say it again.
All students take cocaine.
No, that's haram. Why are they giving you these things? Why are they giving you this? Okay. Yeah. It's clearly not a Muslim school, right? Is it a Muslim school? Naima?
No, it's not.
Okay. Yeah. I'm just joking. Okay. So yeah, this is also recorded. Yeah. Okay. So let's just revise. Okay. So A is TC. Okay. So all stations to Claremont, all students take cocaine, whatever one works for you. So when you're doing a reduction, there are 3 questions that you want to consider, 3 things that you want to work out. Okay. The first thing is, which quadrant am I in? Oh, yeah. So if I say 180 minus theta, which quadrant is that?
Second quadrant. Oh, yeah, second quadrant.
Hamza, you got it? Hamza?
Yeah, I got it. All good.
Okay. And Nafisa?
Yeah, I got it.
Okay. And 360 minus theta?
It's in the fourth quadrant.
90 plus?
It's in the third quadrant.
Which quadrant?
In the third.
Not the third. Not
The
the
second
third.
one.
Oh, sorry, the second.
Second one, because theta is always an acute angle. Acute angle. So if you say 90 plus theta, if theta is like here, right? And then if you say 90 plus, it's going to be there. Do you see that? Okay. And then minus theta?
Is the fourth.
Yeah. Remember, minus is just going clockwise.
Yes.
Okay. And 180 minus is second, 360 plus?
The
First
first.
quadrant.
First.
It's the first, right? First. Remember, when you add 360 to a function, is it changing the function to cos if you add 360?
360.
Does it change the answer?
No, it doesn't.
Why?
Because you went
Full
to the
revolution.
Yeah, it's a full revolution. So the period of the cos graph is 360. What's the period of the tan graph?
180.
Good. Okay. And okay, so you guys know how to work out the quadrant. Then the second question is the function positive or negative in that quadrant? And for that, you use the cos diagram. Okay. So for example, the second quadrant sine is positive, but not cos or tan. And also, third quadrant tan is positive, but not sine or cos. Fourth quadrant cos is positive, but not sine or tan. If you're interested, for those of you who really want to learn more why sine is positive, we've made a video on that. It's called Understanding Trig Functions with Circles. It's under the sections mind map. I show you like why sine 90 is 1, because I don't think they teach you that, like why is tan 90 undefined. They teach you tan 90 is undefined, but they don't teach you necessarily why it's undefined. I find the syllabus, so we made a video on that if you're interested. And then the third category is if it stays the same or if it does the co-ratio. And if it stays the same, if there's a 180, 360, and it changes if there's a 90 to the co-ratio. Okay, so let us just make all of that a bit smaller. So let's try tan, let's say 1 minus 2 times tan of 180. So the first question is, which quadrant is tan 180 minus theta?
Second.
in the second.
Second. And is tan positive or negative?
Negative.
So it's going to be positive. And then is it 180 or it's 180, right?
Yes.
So it stays the same. So just plus 2 tan theta. Great. Sine. Okay, I'm going to ask you individually. Nafisa, do you want to try sine 360 minus theta? Just apply the 3 steps.
So it's negative sine theta because it's
Okay,
in the
but-
fourth quadrant.
Okay, but go like from 1 to 3.
Oh, so 360 minus theta is in the fourth quadrant, and then sine is negative in that quadrant.
Right.
And it will stay the same because it's 360.
Great. So it's minus. So this becomes minus again over here, right? Becomes minus because it's all multiplied. So it becomes minus sine of theta, right? And then what's sine 90 plus? Ayan, you want to try that one?
Second quadrant, it's going to be positive, and it's going to be cos theta.
Great. See, it's easy. Okay, let's try the bottom. Oh wait, that's it. Okay, so that's the first question. So how can we simplify this?
Identity for tan,
Which is
sine over cos.
which leaves you with
The sine, 2 sine times sine, which will give you 1 minus 2 sine squared.
And 1 minus 2 sine squared is identity, I think.
identity for what?
For cos
Cos
2,
squared.
Not
Yeah.
cos squared.
cos 2 theta.
Okay. So do you see how all that is just that? Okay, just shows how they can overcomplicate things. Okay, so next one. What's sine of minus? Okay, let's try Sydney. Do you want to try sine of minus theta? Sine minus alpha? Sydney, are you there? Okay. Hamza, do you want to try sine minus the alpha?
Yeah, sure. So sine of minus alpha is in the fourth quadrant. So sine would be negative.
Yeah.
And so it would be minus sine alpha.
Yeah, and it's 360 minus is the same, so it just stays. Okay. Naima, you want to try cos 180 minus alpha?
It's in sine's quadrant. Cos is negative. It will stay the same. So negative cos alpha.
Yeah. So then this becomes positive in the beginning, and then minus cos of 360 plus alpha. So who wants to do that one? Rivka?
Which one? Oh, minus cos of 360 plus theta. Alpha is that in the first. I'm not sure.
Yes, it is in the first.
Okay. So it will be positive,
Mm,
right?
yeah.
And then
If it's 360,
it will stay the same.
yeah. So minus cos alpha. Okay. And okay, I've lost all of you already. Ayana, want to try sine 180 plus alpha?
Third quadrant, sine theta will be positive.
Yeah, so it's third quadrant, and then it stays the same, right? So
This is identity itself.
isn't this gonna do you make a mistake? Yeah.
Yeah,
Sine is
sine should be
negative.
negative.
Sine's negative, so it's not positive, so it's gonna be plus, right? Yeah. So then it will be 2 sine alpha cos alpha. Because you're adding it, right?
Mm-hmm.
Okay, and then once you do cos squared 180 minus alpha. Naima, you want to try that one?
Negative cos squared alpha.
So breaks first do cos 180 minus alpha and then square it. Because that's how the function is. It's first cos 180 minus alpha squared. So just to cos 180 minus alpha. So which quadrant is it?
It's in sine's quadrant. Cos is negative, but then when you square it, it will become a positive.
Right. Okay, so it's cos
So cos
squared.
alpha.
So it's not, you see it's not negative.
Yeah.
Okay. And then, okay, so Hamza, do you want to try cos 90 minus alpha squared? Okay, Nafisa, you want to try cos squared 90 minus alpha?
It's in the first quadrant,
Right.
so it will be positive cos alpha.
Cos, remember it's 90.
Oh, sorry, sine. So sine alpha squared.
And what's next?
Then you can use
Our
the
identities.
yeah.
They're both
It will-
identities, right?
Yeah.
So what's the
So-
final answer?
It will be
Sine 2
Sine
alpha over
2
1.
over
So it's sine 2
cosine
alpha.
two.
Yeah, so do you guys see just by applying this, you answer this entire question just from Somebody's mic is echoing a bit. Just from this entire question, you can answer just by knowing this concept. Okay. What's next? Okay, that was the last. Oh, there's one more. Okay. It's Nabila's question. Okay, I think she's not here. Okay. Okay. A is the center of O. Okay, so then we're doing analytical geometry, I think, probably. Okay. B is 2, 9. C is 2 minus 1. PB and PC are tangents. So, you know, there's so much information in that statement, right? There's so much information. Okay. So what can you guys tell me about the tangent of a circle? What are the three theorems that you guys know about tangents in the circle? Who wants to go?
The angle between a radius and a tan is equal to 90 degrees.
Yeah, that's the first one. The second one?
Then there's one, the opposite interior one.
Tan chords. Is that what you meant? Tan chord?
Yep. And then if
What's
the tangents start from the same point, then they're equal. So the angles will be equal, which will make it an isosceles triangle.
Correct. We call this the ice cream cone. Have you guys heard of that?
Nope.
Do you see it?
Yes.
You guys see it?
Yeah.
There's the ice cream cone. It's a big ice cream. You guys obviously can't have these now, but I'm just trying to show you what we what we mean by. So Nafisa pointed out that when you've got a tangent coming from the same point, they're equal in length, right? Okay. So now it says find the length AB. So what can we do to find the length AB?
Distance formula.
Yes. What's distance formula? Who's going to give me distance formula?
Square, which will equal to
AB is equal to x2 minus x1 squared plus y2 minus y1 squared all under the root, you know.
Yeah.
Okay.
So if you say d squared, then it's just, so the way I remember this equation is that I say the difference between the x values squared plus the difference between the y values squared. That's an easy way to remember it. You subtract the x values squared, subtract the y values squared, equals d squared. So what's the difference between the x values? What's the difference between the x values?
1.
1,
1 squared. And the y values?
5.
Squared. So d squared equals that. So d squared equals 26. And therefore the distance is?
Root of 26.
Yeah, 2 root 13, I think. No. Root 26 is, just shows the constant, simplify that. Everybody understand that?
Yes.
So root 20, this is the radius of the circle. That's essentially what they're asking you to find, right? Okay. Find, I think that's gradient, right? The gradient.
Yeah.
I think that's gradient. M of AB plus M of AC. What is, okay, this is also easy. How can you find the gradient of AB?
y2 minus y1 all over x2 minus x1.
And who wants to do that one?
So it will be 9 minus 4 over 2 minus 3.
9 over 4, which is 5,
Yes,
over
over -1.
wait, that's not
-1.
is a mistake
Oh,
here.
what?
Do you see the problem? They've labeled this as 2 and 3. Do you guys see the problem? This is 2, and that's 3.
Mm-hmm.
Oh, yeah, they labeled it wrong.
So let us change it, Shane. Let's make it maybe let's make it 1. Make it 1. 1 4. Okay, 1 4. But then it changes the distance, so it's 5 plus. No, it doesn't change it actually. It doesn't change it. That's cool actually. Yeah, it doesn't change it because it's still 1. Yeah. Cool. Okay, and then the gradients become 5 over 1, which is 5, right? I think maybe that's what they meant to do, to be honest. Yeah, okay, 5 over 1 minus 5. Sorry, 5 over 2 minus 1, which is 5. So the gradient is 5. 5, and the gradient of AC? Hamza, you want that one? If you want that one?
-5.
Yeah. Okay, because it's 4 minus 1 over 1 minus 2.
-5.
So that's interesting, eh? Yeah. So can you work out the gradient of this and this?
Of what?
Of BP and PC?
Yeah, you can.
How?
You'll just flip it and change the sign of the like
Because
AB because they're perpendicular.
tangent is perpendicular to the radius. So you can just say this was 5 and this is -5 and this is -1 over 5 and this is just 1 over 5. Okay. Guys happy?
Yeah.
And then they say the equation of OA. Huh? A is the center of O. So how can there be an equation of OA?
Maybe I don't know.
Am I just looking at this in... It says your A is the center of O. So where's O? It's just the name of the circle. So they can't.
Maybe they meant to find the equation of the circle.
Okay, we can do that. So how can you? What's the equation of the circle? Just finding it out. What's the equation? What do you guys know is the equation of the circle?
X minus a squared plus y minus b squared, I think, is equal to r squared.
And you'll notice that this looks very similar to distance formula, right?
Yeah.
And that's because this equation is derived from distance formula. And in the concept video, I explained to you how you can derive this equation and why it makes sense in the concept video on analytical geometry. I urge you all to watch it. So to find the equation, you just need the center and the radius, right? So what's the center?
1 and 4.
So it's x minus 1 squared plus y minus 4 squared equals
5.
what's the radius squared?
Oh wait, that's the gradient.
It will be 26 because we're gonna take the root of 26 and square.
There we go. Great. Okay. Do you guys understand that?
Yes.
Okay. Determine the coordinates of P. I think this was maybe the question she was wanting to answer. I want to hear from you guys what your ideas are. Any ideas?
I think like it's where the two lines are intersecting. Like I mean no.
Yeah, sure. Yeah, that's where they intersect.
So you can equate the equation.
Yeah, you can. So what equation are you going to equate?
BP and PC. If you work at the equation of that.
Yeah.
Yeah, because do you agree that BP equals PC?
Yes.
Another way is you could equate the gradients, because there are two ways, right? So you could say, okay, well, P is the same point. So you can say y minus that over the x value of that equal, oh, sorry, y, if we just, let's just do this, xy, y minus 1 over x minus 2 equals a fifth, and then x minus 2 over, y minus 2, sorry, y minus 9 over x minus 2 equals minus a fifth. Do you see that? So it's still, you still got x over x and y in two equations, so you can solve simultaneously. So there are two ways. So do you want to do both? Must I say it again?
Yes, please.
Okay. So you see, I'm just trying to think to myself, they're asking us to work out the gradients, right? So usually the question that comes before guides you as to what you need to use. There's nothing wrong in doing the the distance, but because they gave us the gradients. So basically what I'm saying is, if let me show you the equation. X, if we find the gradient of BP, it becomes, sorry, it's y, even I think x first, y minus 9 over x minus 2. Do you guys agree? That's BP's gradient, and we know that's equal to minus a fifth. You guys agree?
Oh, yes, I understand what you're saying now.
Y plus 1, which is PC's gradient, over x minus 2. Oh, wow, this is actually on the same x points. I didn't realize that. I wonder if that means that this is going to be halfway. It's a kite. Maybe. I think P is 4. Let's just wait. Let's see. Okay, anyway. Yeah, because the first we can, do you agree that we don't actually have to worry about the denominator, because the denominator is the same?
Oh, it doesn't change.
It doesn't change. So we could actually just replace it and say y minus 9 equals minus 1. No, we can't do it actually. So because x could be. Let's just do it properly. So y minus 9. Let's just take x over. So I mean we could multiply by x
multiply by the negative.
Multiply by x minus 2. Then we get rid of the
Denominator.
x, the denominator. Yeah, sorry. So it's y minus 9 equals minus a fifth times x minus 2, and y plus 1 equals a fifth times x minus 2.
Why is it
And then
1?
we could also make this negative, and then this becomes minus y minus 1. Do you guys agree?
Oh, I see.
Yeah.
Okay, yes.
And then we equate this. So it becomes y minus 9 equals minus y minus 1. 2y equals 8. Y equals 4. You guys see that? I can say it again.
No, I get it. I see.
Naima, does it make sense?
Yeah.
Ian, Nafisa, Sydney. Okay.
Yeah, it does.
And then what's the x coordinate? You can, this is going to be.
Oh no.
So you can just sub it in, right? So if this is going to be, if y is 4, then that's minus 5 times minus 5, 25. That's quite a big x number. So if we let's just move that over there. Okay. So it becomes y minus 9, which is 4. So it's minus 5, because 4 minus 9 equals minus a fifth times x minus 2. If we multiply by the fifth, it becomes, if we multiply by minus 5, so it becomes 25 equals x minus 2. X equals 27.
Okay.
So you see, this diagram is not drawn to scale, but you get the idea. Okay. Do you guys have any other questions? Anything that you're not sure about?
Not at the moment.
Because that was the last question. Any other concept that you're not sure about that you would like me to explain?
I have this question. I just don't understand what it means. So let me just
Sure.
send it to the group. We don't have to work it out.
Okay, you just want to understand. Okay, what it means. Okay. Okay, got it now.
5.4.
Okay, so this is a question that you commonly get. we did a similar question like it last week, but I'll answer it for you. Okay, I'll show you what it means. It basically means, okay, let us draw the graph. It's best to draw the graph, okay? Okay, let's practice. What can you tell me about this graph?
It is in the second and fourth quadrant.
Which graph? What type of graph is it?
It's a exponential.
Parabola.
Oh,
Parabola.
that one.
Yeah, and then what's the first thing that you need to know about hyperbola before you draw it?
It's shifted to the right one.
The
It's
term.
It's in the fourth and second quadrant.
yeah, so it shifted to the. I wonder if I can make it look. No, I can't break it up like that. You guys get the idea. This is asymptote, right? So it shifted to the right by 1. And is there a vertical shift?
No.
No.
Great. Okay. So it's going to look something like that. Do you guys agree?
Yes.
And like that. Okay. So you use the asymptotes as your guide, okay? So they're asking which values of x will the x value multiplied by the derivative of x, okay, be greater than 0. Okay, greater than or equal to 0. So the best thing to do is, all they're saying is you're multiplying the x value by the derivative, or the value of the derivative. So at this point, what is x? Is x positive or negative?
Positive.
It's positive.
And the derivative? How would you know what the derivative is?
We draw tangents.
Yes, tangents, right?
Yeah.
So it's this is the beautiful thing about the hyperbola. Do you guys notice anything about the gradients?
One side's a positive gradient, the other side's a negative gradient.
Are you sure? How does a negative gradient look?
It goes. Oh wait, isn't it both positive?
I want definitive answers.
Both positive gradients.
They're both positive, right? So the entire graph is got a positive gradient.
Yeah.
So that's the subtle thing about the hyperbola, is you notice that the entire hyperbola has a positive gradient. Do you see that?
Yes.
It may go closer and closer to 0, but it's still positive. And if I remember correctly, it's u dash, so it's 0 times, if I just remember correctly, minus minus u, which is minus 1, times the derivative of that, which is that, over x minus 1 squared. This is the derivative of this graph. You don't have to know the approach, but it's 1 over x minus 1 squared. That's the derivative of this graph. That's f dash x. You wouldn't be expected to calculate this, okay? But do you see, what do you notice about this derivative graph? Anybody?
Rep, Oh,
Yeah,
it has a
this is
bounce
the
point.
No.
I don't know.
No. Ayan, any ideas? Yeah.
Nope. I'm clueless.
Afisa?
Same, I don't know.
Do you agree that every number that is squared is positive or not?
Yes.
If this is an equation for the derivative, and I'm telling you that the denominator is always positive and the numerator is always positive, doesn't that mean that the entire number is always positive, whatever value of x you choose? Because you're
Yes.
squaring it.
Oh, I see.
How cool is that, eh? Whatever you choose x to be, except 1. Except 1, because 1, what would happen if x is 1?
0.
Which
It will be
is?
0 squared. It will be 0.
No,
The thing will be
no,
undefined.
undefined.
Okay.
And what happens at x equals 1 in this graph?
It's a
It's the
Undefined.
asymptote.
Asymptote.
So does the graph exist at x equals 1?
No.
Which makes sense. So therefore from this equation you can tell that whatever you choose x to be, it's always going to be positive. Do you see that, Naima?
Yes.
Because when you square any number, it's either naught or positive, and this is always positive. And you can see it on the graph. Can you see that?
Yeah.
The tangents, it's all positive. All positive. So if this is always positive, you don't actually have to worry about the derivative then. You only have to worry about x. So in essence, what the question is actually asking you is, where's x positive? Well, x is greater than when x is greater than or equal to naught. That's where it's positive. That's when x is greater than or equal to naught. But you must say x can't equal 1. Do you understand?
Okay.
Because
Yeah.
at x equals 1, there is no function.
Yeah.
So for this entire all the way up to infinity, x is positive, except here, because this is undefined. The gradient is undefined, right? So yeah, but you understand what they're asking. They're asking when you choose a particular x value, multiply it by the derivative, is it greater than or equal to naught? That's all they're asking you. Okay.
Yeah.
And then just to stretch you one more time, can this equation ever equal naught? For a fraction to equal naught, what must happen? For a fraction to equal naught, for a over b to equal naught, what must happen?
B must be equal to 0.
Not b,
A
because
must be equal.
Oh,
Must equal
A.
to 0.
in other words, the numerator must be 0.
Yeah.
You guys agree? In this function, the numerator is 1.
1.
Can 1 ever be 0?
No.
No.
Therefore, the gradient can never be 0. Isn't this an equation for the gradient?
Yes.
This 1 can never be 0. Because a numerator can, if the numerator is 1, it can never be 0. And therefore, this number can never be 0. Therefore, for this graph, the gradient can never be 0. Which is why the hyperbola doesn't have a turning point.
Okay.
You must, that's exciting, guys. Have they ever taught you about a turning point for the hyperbola?
No.
No.
No. This is why. This is the maths behind it, because this is the gradient or the derivative of the hyperbola. And for there to be a turning point, what did we say?
If
The derivative must be 0.
yeah.
But this number, with this fraction, can never be 0. Why?
Because
the
it's 1.
numerator is positive.
1 will never be 0. Yeah.
And since 1 can never be 0, this fraction can never be 0, the derivative can never be 0, and since this can never be 0, there can never ever be a turning point on the hyperbola. So do you see how we're just applying the stuff that you've been taught in class? But do you understand why they can't teach it to you like this? They can't, because they can't give you the derivative in grade 10 and say, this is why you don't have this turning point, but obviously they don't talk to you about calculus in grade 10. But now that you are doing calculus, I want to show you why. You see? Guys understand?
Yes.
Yes.
Okay. I think that's all right. Yeah. Any other questions?
No.
No.
Naima, doesn't make
No.
sense. The
Yeah,
question.
it does.
Okay. Well, if there aren't any other questions, yeah, I think that's all for today. I'll see you guys on Thursday. I think from you Rivka, you must do the quiz, and you guys must tell me if you like the format of the quiz. If there's anything that we can change. Do you think there's anything that we can do? Do you like the format?
Yeah.
Yeah, it's nice.
And if you do it multiple times, it changes the order and the questions, and
Yeah.
you can't memorize like A, B, C, and all that stuff.
Oh,
Okay,
wow.
I'll see you guys on Thursday.
Okay.
Okay. Eat nicely. Okay. See you.
Bye.
See you, Sydney.
Bye.